Hello my dear students. So in the previous class we have seen the basic of number system. Okay, so already you have got the basic idea about the number system. Especially we learn about four different types of number system, that is binary number system, then octal number system, decimal number system, and hexadecimal number system. Okay, and especially we have seen how we can convert a binary number to the decimal number, and then we have seen how we can convert a decimal number to the binary number. Okay, that means in this chapter, especially after getting the basic about different types of number system, we are doing now conversion method. That means from one number system to the another number system. Okay, because in your examination there will be some question based on this conversion method. So we will focus in detail about the conversion method, and after that we are going to learn about complement method. Okay, so in the previous class we have learned how we can convert a binary number, how we can convert a just a minute. So how we can convert a binary number to the decimal number. Okay, this one is the first method, and the second method we learn about how we can convert a decimal number system into binary number system. So my dear students, in today's class we are going to learn about octal number system. Okay, that means we are going to convert an octal number system to the decimal number system, and then the decimal number system to the octal number system in this class. Okay, and then we are going to learn about hexadecimal number system to the decimal number system, and how we can convert a decimal number into hexadecimal number system. So before we proceed with this, I hope all of you are familiar with this number system. Especially you know what is binary number. Binary number means, that means machine language you can say. Okay, so binary number means we are going to use only two numbers, that is 0 and 1, right? For octal number, our octal number starts from 0 to 7. From 0 to 7 there are 8 numbers. Okay, octal means 8. Okay, so within this range, if any number comes within this range, that means that is a octal number system. Example, say we can say 753. So this number you can say decimal number also, or you can say this is an octal number also. Okay, so in exam, some students, you might be thinking that if a number is given here, suppose 753, so this 753, it is a decimal number, as well as we can say this 753 is an octal number also. But the point here is, you might be confusing that what about this number actually. So in examination you do not have to worry about this, because there will be, in examination there will be like suffix will be given here. Like suppose if this is an octal number, so there will be number will be given like this. Okay, so if this is a decimal number, they will be then mentioning about this number, what is this number. Okay, so you do not have to worry about that. Okay, so why we can say that this 753 is a octal number? Because you can see 7 is within this range, that means 0 to 7. 5 is also there, 3 is also there. But when I write here 793, so then we cannot say this is an octal number, because 9 is not in this range. So what you can say, this will be a decimal number, because our decimal number starts from 0 to 9, right? That means all the number, we can say that number will be our decimal number. Okay, and same concept goes for hexadecimal number also. Our hexadecimal number starts from 0 to 15. Okay, and I have already explained you, that means from 0 to 9 we'll write as it is, and from 10 onwards we'll indicate it by alphabet. Okay, 10 we can indicate it as by A, 11 by B, 12 by C, 13 by D, 14 by E, and 15 by F. So to represent this hexadecimal number from 10 to 15, we will represent this number by this alphabet. Okay, so I hope this is clear to you all. Now we will continue our today's topic, right? So the first conversion method we are going to learn is, that means the third one, octal number to decimal number. That means how we can convert an octal number to a decimal number. Say, I'm giving you a simple example. So we have a number 532. Okay, so this is, suppose this is an octal number. So we can indicate like this, octal, right? So we have to convert it into the decimal number. So that means you can see here 532, you can see here a equal to question mark, you can say 10. That means from octal to decimal we can convert. And in some time in examination they might be giving like this, convert the following number to the decimal number. So in that case, if it is not mentioned like here, then also you can easily identify a thing. Okay. So our point here is how we can convert this number to octal number to the decimal number. See, one point you remember here, if you have to convert any number, that means including what you can say, binary, octal, hexadecimal and decimal, right? Any number to decimal number, if you have to convert any number to decimal number, then we are going to follow only one method, that is multiplication. Multiplication what? Multiplication by that digit into place value, right? Or you can say the place value. Okay, so this is the rule we are going to follow. That means if you have to convert, we have seen already in this case from binary to decimal, already we use the multiplication method. That means if we have a number 101, so we use like this 1 into, because this is a binary number, so place value is to the power 0, this is to the power 1, like that, right? Already we have seen. Same concept goes for octal number also. This is the octal number. So what will be the place value for this? This will be 8 to the power 0, this will be the 8 to the power 1, and this will be the 8 to the power 2. And it will go on like this. If we will have point fraction part here, then after fraction we will write 8 to the power place value, place value will be 8 to the power minus 1, 8 to the power minus 2, it will go on like this. I hope at least this portion is clear to you all. Now we are going to convert this number into decimal number, right? So in order to convert this octal number to decimal number, we first of all we have to find out the place value for each digit. Okay, so our first digit is 500. Let me write it again. Okay, 2. So we'll start from right side, right? So what we'll do, 2 into 8 to the power 0. Okay, then we'll plus with this. What is the place value for 3? 8 to the power 1, right? So we'll multiply like this, 3 into 8 to the power 1, and then for 5 into 8 to the power 2. Now you multiply this, add this, you will get exactly the decimal number. Okay, so 8 to the power 0 is 1, 1 into 2, 2, right? 8 to the power 1 is 8, 8 into 3, 24. 64 5 ja, you can check it out here, 64 5 320, right? So 320. If you add this 3, you can see here 6 4. That means the decimal number for this octal number is equal to what? 346. You can write here it as 532 octal number, okay, equal to 346. This is the decimal number we have got. Okay, now the same method, if you want to convert from decimal to the octal number, as you can see here, from any number to decimal number, we will always follow this multiplication method. Multiplication means the base or the place value will be different. Okay, because for octal number it will be 8, for binary it will be 2, for hexadecimal it will be 16, right? Now reversely, if you see from decimal to any number, okay, from decimal, this is very what you can say, this is one kind of trick, okay, because in examination there will be any number, from any number to the decimal number, and from decimal to the any number. Sometimes most of the students, they used to get confused in this point, whether they have to multiply or whether they are going to divide it. So okay, so for them this is a short trick, you can note it down, right? Okay, from any number to decimal number, we are going to follow multiplication. Multiplication means this is how, okay, and division means what? You can see here, from decimal number to any number, always we are going to use division method. Just remember this one, we are going to use division method here. Division means what? In what you can say, in binary number, from decimal to the binary, suppose we have a number 342, so we use to divide by 2, because we are ultimately we have to convert this decimal number to the binary number, so we have to divide it by 2. In order to convert from decimal number to the octal number, we are going to divide that decimal number by 8. In this case we use this one, right? So already we have seen how we can convert an octal number to the decimal number, and now we are going to see how we can convert a decimal number to the octal number. Okay, so please note it down, because in exam I know most of the students will be confused in this part, whether you have to multiply or you have to divide it, right? So please note it down. Now I am going to show you how we can convert a decimal number into a binary number. Okay, so the fourth conversion method, that is decimal to octal number. So suppose we have a, let's take this decimal number only. So our decimal number is suppose 346 decimal number, and this time we have to find this numbers octal number, right? So for that we are going to divide it. Our number is 346. So let us divide this number 346. This time we are going to divide it by 8. In this case we divide that number by 2. In this case we are going to divide it by 8, right? So 8, okay, 26, remainder is 2, okay, then okay, remainder is 3. So this 5 is smaller than this 8, so we cannot divide it anymore. So it is very simple, we can write it here, 346. This was our decimal number, and our octal number is 532. This is the octal number. You can see here, this is matching. Okay, so this is how we can convert an octal number to a decimal number. Okay, and this is how we can convert a decimal number to the octal number. Same method with this number 1 and number 2. So with this we can we are done with this 4 method. Okay, now I am going to take one more example by taking fraction this time. Okay, and here also we will be taking fraction, then we will see. Okay, actually this conversion method and this conversion method, okay, this 2, 4, 6, this 6 conversion method is similar. Okay, that means here we are going to use multiplication or division method, and in what case we have to divide, we have to go for divide method, and in what case we have to go for multiplication method, that one I already give you the hints. Okay, so now let's take another example. This time I'll take with fraction. Please note it down. Okay, in order to note down this exercise, please pause this video and then note it down. Okay, now let's take one number, suppose one octal number, suppose 724.13. Say this is the octal number and we have to find its decimal number, right? So this is our integer part and this is our fraction part. You know this part, okay? And integer part always we used to count from point to the left side, right? And for fraction from point to the right side. Okay, especially what is the place value for this? since we are talking about octal, so this will be 8 to the power 0, this will be 8 to the power 1, 8 to the power 2, this will be 8 to the minus 1, 8 to the power minus 2, it will go on like this. Okay, so our number is 700, we'll write this integer part 24. Okay, so in order to get decimal of this number, we have to follow, right, multiplication, right? So 4 into 8 to the power 0 plus 2 into 8 to the power 1 plus 7 into 8 to the power 2. So after multiplying and adding, we will get the decimal number for this integer portion, right? So this will be what? 1 into 4, so 4 plus 8 into 2, 16 plus 64 into 7. So 64 into 7, you multiply it to 448, right? So 448. Now you add this, okay? $468. That means our decimal equivalent for this octal portion we are getting 468. Now let's find out for this fraction part. For fraction part, in this category, or you can say in this binary to decimal, we use what? Again multiplication. But how we did? We used to take, like, suppose our fraction part is 0.13, we will multiply it by 8, right? So let's multiply this. Okay, again we are getting fraction, that means 0.04 into 8, so 0.32. Again we are getting fraction part, that means 0.32 into 8, it will be okay, again we are getting fraction part 0.56 into 8. So it will go on like this. So like I said in the previous class, just try to show 5 to 6 term multiplication, then you can give dot 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 if you are not getting exactly 0 0. Okay, so that means our decimal equivalent for this fraction octal number is 1024 dot dot will go on like this, right? So what we can write here, our ultimate answer will be 724.13 equal to 468.C. In this case, we will take from top to the bottom, right? So what we'll do? Sorry, there is a mistake. Okay, so this is my mistake. Okay, for this fraction part, we have to multiply it by. So fraction part is, this is my mistake. Okay, for fraction part we have to take, suppose our number is 0.13, right? So place value for this, or you can say 1 into 8 to the power minus 1 plus 3 is here, so 3 into 8 to the power minus 2. So that method will be used for decimal to octal. Okay, it was my mistake, please. So it will be 1 by 8 plus it will be 3 by 8 cube. 8 cube means what? 64, 8, 512, right? So 1 by 8 plus 3 by 512. So divide it. This is quite lengthy, okay, in this number system. So 512, you divide it, so we will get 64 plus 3, 67, 502. So you divide this number and that fraction part you add with this. Okay, I leave this division method up to you. You have to solve it. Okay, so ultimately what we can say, our decimal number for this octal number will be 468. This one is correct. And point, after point, what you do, you divide this number and that fraction part you write here. I am giving here dot dot dot. I am leaving you this up to you. Okay, so this will be your decimal number. Okay, now same concept goes for, now let's take this the decimal number and convert it into this portion. Okay, let's start this. I'm going to wrap this part. Okay, so this time in this case, suppose our number is 468 point. Suppose some numbers are there. Okay, we will not get exactly. First we have to find it out. Okay, so you find it out down. Suppose I'm giving here another fraction part. Suppose we are having 68. Let's say after dividing this number, here we are getting 68. Okay, so again I'm telling you this, I'm leaving up to you guys. Okay, you have to divide this number and exactly that fraction you have to write here. Okay, since it will take time, so I'm leaving it up to you. Now here also you take this integer part and fraction part. So integer part, it is very similar. Like I said, from decimal to any number we are going to follow the division method, right? So in this case our number is 468. So what we'll do, we will divide this number. Okay, let me write in next step. Okay, 468. Let me wrap this part. Okay, you note it down and you solve this division method. Okay, then you put here. Okay, so now you divide this number by 8 because we are converting from decimal to the octal. Okay, जैसे कि हम लोगों ने किया था in this decimal to binary, same रूल अप्लाई करेंगे हम लोग डेसिमल टू द ऑक्टल नंबर में. ठीक है, तो यहाँ पे हम लोग जो नंबर है 468, तो ये नंबर को हम लोग क्या करेंगे 8 से डिवाइड करेंगे. ठीक है, तो ये नंबर क्या है 468. फ्रॉम 8 इफ यू डिवाइड बाय 8 then 568, right? So for 68, remainder is 4. Then again if you divide it 2. Okay, now 7 is smaller than this, so we can write here. As you can see here, our integer part we are getting here. Integer part means what? 468. This is a what? This is a decimal number and octal number is 724. So you can see here in this case octal number was 724.13, and for this integer part portion we are getting, this is the decimal number, decimal number. And in this method what we are doing, decimal to the octal. So decimal number it is matching, that means this is correct. Okay, now this fraction part I am taking, I am assuming that after dividing that method we are getting 68, assuming. Okay, so you have to do this part. Now let's see how we can solve this part. So for doing that I'm going to show you here. Okay, so the number here is 0.68. So in this case, for this fraction part we are going to apply that multiplication method. That means 0.68. This time we are going to multiply it by 8. Okay, so 64, 6. Okay, 52. Next 0.24 into 8. So 3, 9. Okay, now again fraction part is 92. Multiply it by 8. So this time 6, 1, 73. So it will go on like this. Okay, you try for 5 to 6 terms. Okay, after that also if you are getting exactly this fraction part, okay, once you get 0, 0, then fine, no need to do. But still if you are getting after 5 times 6 times multiplication also, if you are getting this fraction part, then you can give dot 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 like this. Okay, so ultimately in our octal number for this the integer part is 724, right? So what we can write here 468.68 equal to for this integer portion we are getting 724 point, and for fraction part, that means for 0.68 we are getting it 517. It will go on like this. Okay, we'll take integer portion, only, and this is fraction part. So we'll take only this integer portion. Okay, for this number we are getting 5, so 0.5. For this number we are getting 1, so 1 here. For this number we are getting 7, so 7 here. Still we are not getting, that is why we are giving here dot dot dot. Here also you give dot dot dot. Okay, and what is this number? This number is an octal number, so you can within bracket you can write like this. So this is how we can convert from octal to the decimal and from decimal to the octal number, right? So I have given a simple example with this, okay, by taking fraction number and by taking, or we can say without taking this fraction number. I hope this 4 numbers conversion method is clear to you all. Okay, in the next class we are going to start these 2 conversion method. Okay, so thank you, see you in the next class.